In the previous videos on set operations, I realized that I had not discussed the product of sets. So that's what we're going to do in this video. If we have two sets A and B, the product of those two sets is denoted like A cross B. And the way it's formed, it's going to be the set of pairs that you would take by taking one element A from A and the second part of that pair as an element from B. Okay, that gives us the set of pairs. Now, let's take a look at an example here. Supposing A is going to be the result of, say, tossing a coin, and it can be a head or a tail, and say let B be the result of rolling a die and getting some number 1, 2, 3, 4, 5, 6. We'll write it all down. Now, how do we form the set of all possible pairs here? Well, we would let the elements of the set A form the rows. So I can write heads and tails as the two entries there, each designating a certain row. And then the elements of the set B are going to play a role in the columns. I guess I should write them all down here. Now, how are we going to then form these pairs? Well, here is everything in the H row is going to have to start with an H. So it's going to be H, and then it's going to pair with 1, and then H2, H3, H4, H5, and H6. And then each of the second elements in the set A, the T, is going to also have to pair with each of the die results. So it'd be T1, T2, T3, T4, T5, and T6. Okay, so that's will be the collection of all possible outcomes that we're going to get when we take these product of these two sets. Now, very often we're not really interested in writing down exactly what the sets are, especially if the large set of outcomes here, but we are interested in how many they are. So how do we get the total number of elements in here? Well, it's just going to be the number of rows, which is the number of elements in A. So if we say the number of elements in A cross B is going to be the number of rows, the number of elements in A, that's the number of rows, times the number of columns, which will be the number of elements in B, okay, and so in this particular case, it's just going to be we had 2 rows and 6 columns, and so there's the 12 elements that we had. Okay, let's look at a couple more examples here. First of all, a typical case might be where we toss 2 coins. Okay. Now we should make these coins distinguishable, so one should be nickels, for example, and maybe one would be dimes. And so we'll have nickels as the first column, or first set, so that will go in the rows, and then the dimes will go in the columns here. Now, what are the possible outcomes? Well, you could see what you're going to get. You're either going to get 2 heads, or you get a nickel head, and a dime will be a tail, or you can get a tail's heads and a tail. But that's pretty straightforward. Now, let's do another example where we soup it up a little bit more. Supposing we toss 2 die. Okay, now we should specify these. One maybe is red and the other blue, just so we can distinguish them. Now, what are the outcomes going to be on these things? Well, we'll put the red die over here in be the first set, so that'll go down the rows, and then let's put the blue die over here, make them columns. So we're going to have 1, 2, 3, 4, 5, and 6 here. Now, what are we going to have? Well, each of the red ones is going to have to appear, for example, in the first row. Okay, and then we'll have 2s in the second row and so forth. 6s will be in the third row. I mean, sorry, 6s will be in the sixth row here. Now, and we're going to have all these other things, which I won't take the time to fill in. Now, what about the blues? Well, the blue ones will all appear in the first column. So we will have a 1, 1, and so forth down to 6, 1. Blue 2 in the second column. All of the second entries will be blue, and so forth with 3, 4, 5, and 6. So you see there's going to be quite a few of these here. That's why I'm not going to fill them all in. But let's go back to our formula to calculate how many are we going to have here. Well, you see we have 6 rows and 6 columns. So we're going to have 6 times 6 equal to 36 different entries. And you can visualize what they're going to be if, in fact, we then start to split these off into, for example, look at the possibilities where the sum of the dies are even or something like this. Now, a natural question that can be asked is, well, we've only dealt with 2 sets here. What if we have 3 sets or more? How do we visualize these and interpret them? Well, let's go back to the two coin problem and look at this table in a different way. Supposing we take that first coin, and what we want to do is to view this as a tree. So the first coin gets tossed is going to have a head or tail. Now the second coin, if we toss that, it's going to be a head or tail. Well, the first coin could be a head. You see the first row of this was the head row, and then we had a head or tail going with each of that possibility. And the second row was a tail row, and so we had to combine that tail with each of a head or a tail here. So this can be visualized as a branching of a tree. And now notice that each of the total branches correspond to one of the entries in this table. See, this was just going to be the head, and this was a head tail. Here was the tail head cell and the tail. So drawing this tree is really equivalent to drawing a table like this. Now, but we can extend this. What happens if we have a third coin? Well, each of these entries gets split into a head or tail. So from this entry, we can have a head and a tail and a head and a tail. So here's this third coin. We keep getting split. Head and tail. Okay, now what are the different possibilities that come out of this? Well, from the head entry after the first 2, you see that gets split by the third coin either being a head or a tail. Now in the second case here, we had a head-tail result after we tossed 2 coins, and the third coin then can either be a head or tail, so we'll have to consider each of those possibilities with the outcome of the second coin. And we can continue this on. You see here we had a tail heads, and then they get split with a head or tail, and then finally we had the tail possibility corresponding to the cell over here, and then that gets split as a head tail. All right, and this actually lists all the various possibilities that we had. Now, what if we just wanted to count them? How do we see how many there are? Well, we noticed that there were 4 possibilities here in this table. There's the 4. So we had the 4 here. We don't need that. And in the third coin, we got 2 possibilities there, and so we had each of the 4 times 2 to give us a total of 8 possibilities, and there they all are. We can actually enumerate them. Now, how can we go back and look at this to maybe split it up in case we don't know this 4 here? Let's look at the composition again. So notice the first coin, there were 2 choices there. That first set had 2 courses. The second set actually split each entry here into 2. So we had 2 choices for each of the choice that we had here. So this gave a 2 times 2 or 4. And then the third set gave us 2 choices there, and that's how we ended up with 8. So we could have just written this 8 as 2 cubed. So if we had had a fourth coin, it would be 2 to the 4th power, and so forth. Okay, so what we've tried to do here is to indicate what a product set is and how you calculate its number. Thanks for watching.